Hey guys, hope you're all doing okay. This is Roghat and welcome to the complete tutorial of RPCS3, the PlayStation 3 emulator. In this video, you will find everything that you need to know about the emulator, how to set it up, what do all the options mean. I made a guide like this last year, but a lot of things have changed since then. This is going to be a detailed video and I'm gonna put timestamps in the description, but I do recommend watching the entire video if you want to understand the emulator in depth. So without further ado, let's get started. To give you guys some context, these are the minimum specifications and these are the recommended specifications. To make sure that we get maximum performance, I'm gonna explain each option in detail, but I will divide them in three categories. Ones that should always be turned on or off regardless of the specifications, ones that are specification dependent, and the ones that are experimental. You will follow this guide in that order, but if you've tried the first two options and you're still facing issues, you will go with different combinations of the experimental options. The most likely cause of these issues might be the unplayability of the game, or a feature of the emulator interfering with the game, or low specifications of your PC. And lastly, just make sure to have all these things checked. In this section, I'm going to give an overview of PS3 hardware and RPCS3. PS3 architecture is one of the most complicated ones in the computing history. RPCS3 has been in development for more than a decade at this point, so that should give you an idea how complicated it was. Regardless, its complicated structure is what made it so powerful, even competing with some really powerful PCs. If you want to know about the architecture in detail, watch the MVG video on PS3, link is in the description. PS3 consists of PowerPC based architecture, Power Processing Element PPE, which contains Power Processing Unit PPU, Synergistic Processing Elements, which contains the Synergistic Processing Unit SPU, and GPU, which is RSX Reality Synthesizer. The GPU was based on NVIDIA G70, more specifically GTX 7800. Yeah, PS3 is really based on GTX 7800. I remember RPCS3 when it came out in 2011 and I was just staring at a little debugger window hoping to boot AAA titles on there, but back then it could only run a couple of lines of the firmware. And now it's a beast of an emulator. Massive kudos and thanks to developers and Patreons and supporters. Okay, so one of the most significant accomplishments of RPCS3 is that it can now boot every single PS3 game. It means that it has no game in nothing category. It doesn't mean that you'll get 60 FPS in every game, but you'll be able to at least boot into them. This is extremely impressive, and PCSX2, the PlayStation 2 emulator, just recently accomplished this. Here is a detailed list of all the improvements, changes and modifications since I made the last guide, which was February 2021. PPU models can now be launched before the game loads, meaning less stuttering and break-ins in-game. Shader cache code restructure, meaning games with high texture upload are going to be performance optimized. VRAM memory management optimization, which means clever usage of VRAM. MLAA patch fixes, which means morphological anti-aliasing, eliminating or at least minimizing the distortion artifacts when rendering a higher resolution image at a lower resolution. PPU LLVM optimizations, general performance improvements of course. AMD's Fidelity FX Super Resolution upscaling, 2.4% performance increase, 4K potential ray tracing improvements, not as enhanced as internal resolution though, but upscaling still beneficial. Works for games that don't work with internal resolution. Optimized shader interpolation, which is gonna give you shader enhancements. Indexed texture attribute fetch, which is gonna make the whole indexing process much optimized. Precise Z-Cull, which is gonna fix your brightness and lighting. And V-Blank, which is another experimental option that we're gonna get into later. To download the emulator, we have to go to rpcs3.net and download the official binary. You can go to the GitHub page and download the latest commit releases, but their update cycle is pretty good and there is an option within the emulator which prompts you to update. In terms of prerequisites, we need to have Visual C++ 2010 to 2020 libraries installed, both x86 and x64. Link to the standalone version in the description. If you've got the prerequisites installed and everything in order, the emulator should launch without a problem. Now, before we can start running any games, we need to install the firmware. I would recommend dumping the firmware from your PS3 console, but there is a link in the description if you want to download the firmware from PlayStation's official website. The good thing about RPCS3 is that you don't need to decrypt your firmware like Ryujinx or Yuzu. You can just install the PUP file. After installing the firmware, it's gonna install some of the required libraries and some runtime repositories. That's totally normal. Okay, so now that we have everything set up, let's go through the UI and see what we're working with. In file, we have boot self and ELF. Self means signed executable and linkable, or self-executable and linkable format, or ELF. These are the boot files for PS2 and PS3. In some scenarios, if you want to boot up Homebrew or just a boot file for a game, you can do it here. I used to do this with Codebreaker and Action Replay, which are cheat code systems for PlayStation 2. Next option is boot a game. There are a couple of ways you can boot up games in RPCS3. It all depends what kind of game dump you have. Is it an ISO, a PKG, or a decrypted repository? This option is for the decrypted or installed folder. After that, we have VSH XMB boot. In July 2021, this feature was added in RPCS3 by their amazing team. Now you can boot up the actual PlayStation OS. Kind of. The screen that you saw when you booted up your PS3, that's what you're gonna see here. I'll actually show you. Massive kudos to RPCS3 devs because this feature is gonna unlock unlimited potential for our community. In boot recent, you're gonna see the recent files and games that you might have booted. Next up, we have add games. Here we can specify the directory in which all of our games are, and it's gonna show up here. After that, we have install packages, wraps, edats, etc. Okay, so there's a lot to unpack here. First up, if you have a package file, PKG file of a game, you can install it and it will show up in your games directory. It's like an executable exe file but for PS3. And you can think of RAP and EDAT files as keys or licensing information for some specific region games. We need those files for some games, otherwise they won't boot because of PS3's security mechanism. Using this option, you can initialize those files alongside the games that require them. Install firmware, we've already gone over this. In all titles, we can create PPU caches if you want to optimize your PPU caches, or you can remove your custom configurations and other existing caches. So sometimes your cache can get corrupt, so it's a good idea to make a new cache, but then you're gonna have to play the game all over again. So make sure it's not an open world game before removing your caches. We also have the create firmware cache and remove firmware cache. So if for some reason your firmware cache is corrupt, you can remove it and then create a new firmware cache. And exit is pretty self-explanatory. In emulation, we have resume, stop, restart, send, open system menu, CMD, send, exit, CMD. This is all pretty self-explanatory. In configuration, we have different options. We're gonna go into them in just a little bit. In manage, we have virtual file system. We can specify different folders, kind of like the actual PS3. User accounts, save data, wrap files, and trophies are pretty self-explanatory. These are going to give you access to your specific data. Next up, we have Skylanders Manager. If you want to play Skylanders without the portal on the PC, you can use this option. If you want in-depth explanation regarding this feature, link is in the description. Screenshots is also pretty self-explanatory. In game patches, we can apply different patches to our games. For example, some games brightness might be too much, so we can apply a decreased brightness patch and stuff like that. And I'm also getting a prompt here that says update patches, and we can also update the patches here. In cheats, using the cheat engine database, you can edit your hex data and do some cool stuff with it. We're not going to go into that in depth, but I am going to link a video in the description if you want in-depth explanation regarding the hex editors and cheats. Utility, we mostly have debugging options. Most useful of them is log viewer, which is going to let you view all the activity up until now. Other tools are mostly memory and decryption related. If you want to explore kernel or decrypt PS3 binaries or boot files, you can do them here. In view, you can customize what attributes would you like to see in the UI in terms of games or emulator flags. In help, we have the about section and the update section. Within configuration, we can pretty much click any of them and it will take us to the specific tab in the generalized settings area. Okay, let's start with the CPU settings. And in PPU decoder, we have 3 options: interpreter static, interpreter dynamic, and recompiler LLVM. Always go with the recompiler LLVM. Interpreters are mostly useful for debugging purposes because it can translate code line by line. In SPU decoder, we have the same options, but we also have the ASMJIT recompiler, which is just-in-time recompiler. You will use LLVM recompiler in both PPU and SPU, but if you're facing some runtime or performance issues, it is a good idea to include JIT recompiler in your experimentation. Enable SPU loop detection is a good performance option for mid to low end PCs where it tries to detect a loop to give you better performance. However, in some cases it can give you terrible stuttering, mostly with boot only games. SPU exfloat accuracy is a method where you get accuracy by sacrificing performance. Even on some high-end PCs, it will give you slowdowns, but the advantage of this is that it is close to perfection when it comes to the emulation, but it is use case dependent. Let's say I'm stuck in a particular area in the game and I can't progress further because of some terrible glitches or bugs. I would then enable this option to get through that area of the game, and then I would disable it again. Next option is full width AVX512. This is for the people with the new Intel 12th gen CPU, and can I say it will give you a monstrous boost in performance. AVX512 is one of the latest and most powerful instruction sets available in CPUs, and it is a godsend for emulation. I'm kinda sad because my 5900X doesn't support it, but I digress. TSX is also another instruction set supported by Intel's processor, but mostly new ones. So if you see it grayed out, it means you're using an AMD processor or an older Intel processor. SPU block size, we have Safe, Mega, and Giga. For some games, it could help to go with Mega and Giga because it will tie bigger units together and it could help with the compilation. But I haven't come across any games that could benefit from this option. Please include it in your experimentation. Preferred SPU threads, we're gonna keep it to auto, let the emulator decide, but you can select from the drop down list depending on how you want your resources to be allocated and prioritized. Same idea with the thread scheduler. If you've got a lot of threads, you can let the emulator prioritize those threads, but it's gonna be grayed out if you've got less than 12 threads. That generally means less than 6 CPU cores. Let's move on to the GPU settings, and first up we have the renderer. General rule of thumb is to go with Vulkan in majority of the scenarios. It's fast with efficient compilation times, shader building times, and outstanding compatibility, and the code is well put together. But it has a big con in some scenarios, and that is accuracy. In terms of accuracy, OpenGL is still amazing. For low-end PCs and cards, Vulkan might not be available, so you won't see Vulkan in the drop-down menu. But if you have Vulkan available, definitely go with that. You will only use OpenGL if you're having accuracy issues, have a low-end PC that doesn't support Vulkan, or the game isn't fully playable yet, and Vulkan is interfering with that game. Graphics devices for PCs with multiple GPUs, choose the dedicated one or the faster one in here. Aspect ratio and frame limiter are pretty self-explanatory. I find frame limiter pretty useful in lightweight games where FPS can jump to 300. Anti-aliasing is a technique to remove distortion artifacts and deal with rough edges on your screen. I would recommend keeping it to auto, but if you've got a low-end PC, please turn it off. Anisotropic filtering is a technique to enhance or clarifying textures when at specific angles. Older games suffer the most from this issue. Got a mid to high-end PC? Enable it, otherwise keep it disabled. And I would also recommend keeping it to 2x, maximum 4x, because at higher scales you're barely gonna notice any discernible differences, but it will add unnecessary computing, hence impacting your performance. So far so good? Alright, then we have Z-Call. Let's say we're playing Red Dead Redemption and we come across a bar. Now, that scene is fully rendered, right? But do we need to render the stuff behind the bar? We could potentially save some computing and gain performance by not rendering that stuff. Here you can define the parameters for Z-culling. For high-end PCs, I would suggest leaving it on because it will give you a bit more accurate and smoother experience in some scenarios. For compatibility reasons, RPCS3 suggests playing at 720p, but if the game you wanna play is showing up as fully playable, then you can play at higher resolutions. But for ones that can only go up until boot screen, the safest option is 720p. And then we have the resolution scale. Let's say we increase it to a value of 200%. It means that for a 1280 by 720 meaning 720p game, RPCS3 will render it at twice the resolution, 2560 by 1440, so 2K. 300% is 3840 by 2160, which is 4K, and so on. But what's the point of this slider when we have the drop-down menu option right here? In the slider, you can increase or decrease the resolution in 25 increments. Resolution scale threshold is another option related to upscaling, and I would categorize it as experimental. What it does basically is set a limit for bitmaps frame buffers. It won't upscale anything that is above that limit for frame buffers. For example, right now it is set 16 by 16. A frame buffer of 32 by 32 won't be upscaled, so this threshold can fix some artifacts issues of some specific games. But I would recommend increasing or decreasing it using doubling sequence like 32 by 32 or 64 by 64 or 128 by 128. Next up we have FSR Fidelity Super Resolution Upscaling. If you've got a beefy GPU, try turning it on. It can enhance your upscaling. So to put it simply, there are two types of upscaling. One is that takes the frames and put it through an algorithm to give us upscaling. It's not always guaranteed to give us the best results, but some algorithms such as FSR are more elaborate and give you good upscaling and performance. I would recommend taking turns with the upscaling techniques to see which one gives you the best performance gains and the best upscaling, whether the default resolution scale or FSR scale. And after that we have the RCAS sharpening strength. To make things simpler, it's essentially an intensity slider of the upscaling. Please leave it to default because increasing it will take a toll on your performance. But if you've got the GPU memory to spare, you can experiment a little. Okay, let's look at the shader mode. This category and GPU render are closely related. So if you want to experiment, then string a group of settings together. The experimentation is mostly gonna be for open world games. Legacy single-threaded option is probably the most accurate one since it's been through so many iterations, but it will be incredibly slow, and given the state of the emulator, this won't be useful except in a very short handful of cases. Then we have async multi-threaded, which is the only option you're gonna go with in pretty much every scenario. If you've got a low-end GPU, you might experience texture pop-ins because nothing will be rendered until a shader is compiled. Async with shader interpreter is the same option as this one, but instead of nothing rendering and waiting for the shader to be compiled, interpreter will be used until then to give you an approximation of the emulator, sort of speaking. But keep in mind, it will be slow for those short bursts. I would recommend keeping it async multi-threaded. The last one is for debugging purposes only because it's not gonna compile and only the interpreter is gonna be used. Number of shader compilation is always gonna be auto unless you've got multiple workloads at the same time and want to specify the load threshold. Right color buffers is an experimental one. Majority of the cases, if a game status is in-game and you get broken lighting or complete darkness, try enabling this option. Strict rendering mode is for a very few scenarios and again is an experimental option. If you enable this, the resolution scale and threshold will be disabled and it will stick to the most compatible settings of the API. For example, OpenGL will use the most compatible settings possible to give you the most compatibility. It can work in a handful of games where nothing else is working. VSync is for fixing tearing artifacts in your game, but it can take a toll on your performance. Use it on a per game basis. Stretch to display overrides the aspect ratio to utilize the entire screen. Enable 3D will enable the 3D effects if you have a 3D compatible display, but only anaglyph stereoscopic will work. To me, it's just a gimmick. Next up we have disable vertex cache. I would recommend keeping it like this and not disabling it because cons outweigh the pros, but you can use it as an experimental feature if you get missing graphics, flickering or artifacts. Multi-threaded RSX, which is a reality synthesizer, should be enabled on mid to high-end PCs, especially CPUs with 4 or more cores. Asynchronous texture streaming will try to utilize the full extent of your GPU to give you more performance by doing 2 workloads in parallel. So if you've got a GPU from 3000 series, it is a very good option with above average compatibility. Let's move on to the audio settings, and the first option we have is audio out, and we have 2 plugins in here, QBEB and X Audio 2. RPCS3 recommends choosing QBEP first, but you can fall back to Xaudio too if the first one is not working. You should know when you're getting audio stutter or bugs because you're not getting enough performance from your game. But if the video output is competent and still the audio is stuttering, then you can experiment with the audio renderer. Audio channels will let you choose an audio profile for audio files, but I would leave it as it is. Audio settings. Convert to 16-bit will convert the audio to 16-bit. Again, it's an experimental option and I would recommend keeping it disabled. Music handler is QT, we're gonna keep it like this. And then we have the microphone settings. I have disabled all the microphone and this is the default setting, but you can enable them if you want. RSX audio AV port is gonna let you specify from where do you want the audio to be coming from. Is it gonna be the HDMI 0, HDMI 1, AV multi-out, SPDIF 0, SPDIF 1? A very niche option in my opinion. In volume, we have the master slider for the emulator, so if you want to increase or decrease the volume, it's here. Audio buffering is always gonna be enabled because while you can get some extremely slight performance gains in case of low-end PCs, they won't be worth it in most cases. This option will buffer the audio first before processing so you'll get a smoother experience. And in the next part, you can get into the specifics, the nitty-gritty of all these. Buffer duration and this threshold will allow you to get airtight synchronization for your audio in games, but I will recommend keeping it to default like this is right now. That's all regarding the audio settings. Now let's move on to the I/O settings. First up, we have the keyboard handler, which is set to null. You can choose basic for some basic functionality and it's supported by a handful of games where they can take basic keyboard inputs. Mouse handler is pretty much the same thing. In move handler, you can utilize PS move with your mouse. By selecting fake, you can utilize PS3 controller mappings. So pad handler mode is gonna be single threaded if you're playing single player, but you can use multi-threaded if you're playing multiple players. But for low-end PCs, I would recommend keeping it to single-threaded, and if you've got a high-end PC or even a mid-end PC, you can choose multi-threaded where every controller stream is going to have its own thread. For some specific games, you can select the camera type and the hardware device. The rest of these options are pretty self-explanatory. And then we have some game-specific settings, so we're going to move past that. And the rest of these options are pretty self-explanatory. RPCN is a sort of net play that you can use that emulates P2P. Let's move on to the advanced options. First up is the debug console mode. It will raise the system memory to match the system memory of a developer unit. I can't think of a specific use case for it other than debugging. Accurate DFMA is enabled by default. Most of the processors today support FMA family of instruction sets, so please leave it enabled. But if the processor is older than 2012, then you can disable it. Accurate RSX reservation access is another experimental option. Enabling it might help with games that crash in-game, but it will take a significant toll on your FPS. For legacy purposes, we can enable PPU non-Java. These 5 options are for PPU backends. They are experimental for games that have accuracy issues, but they are really specific and don't improve performance that much. Pre-compilation of PPU LLVM should be kept enabled because it will compile the required modules during boot. So every time you boot a game, this will compile the necessary modules and your gameplay won't be interrupted in this regard. Delay each odd MFC command is only for debugging purposes. Silence all logs is gonna disregard all the log keeping. Enable it if you must. Rest of these options are specifically case dependent and I would recommend to keep them as they are. Moving on to the 2 experimental options here, sleep timers accuracy is another experimental option, and if you've got a specific issue and you've tried everything, it might be worth to just try all timers or as host, because it can affect your performance in some very specific scenarios. Maximum number of Spurs threads, we're gonna keep it to unlimited default. After that, we have the firmware libraries. Here we have a bunch of libraries that we can either enable or disable. You can enable or disable these libraries if you want to specifically experiment with a game. So if you know what kind of issues a game is suffering from, you can enable or disable one of these libraries and it might help the compatibility. Moving on to the buffer options, you will find that some of the playable games will suffer from stuttering and severe artifacts, and it can happen on some of the relatively older GPUs. To mitigate this, you can experiment with these options to fix that. Next up is the Vulkan queue scheduler, and I would highly recommend keeping it to safe. This option is in reference to asynchronous streaming, so basically we're gonna keep it to safe, but you can select fast if you have an AMD GPU. Again, it's an experimental option. There's a great article from RPCS3 team and it explains performance gains in simple words. I highly recommend checking it out, link is in the description. RPCS3 recommends not to change these settings globally, meaning we don't want to change them here, but rather locally on a per game basis. I'll show you how to do that later on. These are not performance oriented settings, but rather experimental options for game compatibility. To put it simply, driver wake up delay is the time window you need to wait for the GPU to respond. In some games, due to compatibility issues, if the GPU doesn't respond fast enough, it can declare the game as frozen and give out an error. By having a large time window, you can wait a little longer for the GPU to respond. Again, now that all the games are bootable in RPCS3, this is becoming extremely niche. Moving on to the next option, if you have a high-end PC, you might want to tinker with V-blank frequency. It can modify your frame rate cap so you can utilize higher frame rates, given that your PC and the game you want can support it. Most of the times you want to keep it to default and use it at a per game basis. You can specify your custom parameters for clock scale. This is another experimental setting. For the games that can utilize higher clock scale, you can increase it by increments. And here we have the specific emulator options. I think they're pretty self-explanatory, so we're not going to go into them. And here are the GUI options if you want to customize the look and feel of your emulator. Let's go into gamepad settings. In handlers, we have the keyboard, DualShock 3, DualShock 4, DualSense XI input, and joystick. You can select your specific input type if you have a controller or a keyboard or some other controller. In devices, we have keyboard because keyboard is the only one that's connected right now. And you can make different profiles for different games. If you want to tinker with specific pressure sensitivity modes, you can do them here. And in device class, we can select different types of input methods like a guitar or a drum depending on the game. In here, we can adjust the sensitivity of our controller sticks. So there we have it, guys. We have covered all the settings and now we're gonna add some games. So to do that, we're just gonna go into File and Add Games. After selecting your specific folders, your games will appear here. And here we can see the serial number, the version, the category, PlayStation Move, supported resolutions, time played, and compatibility. Okay, so these games are gonna play differently with different settings and we want to make sure that we have optimized settings for each of these games. How do we do that? We're just gonna have to right click on a game and then we can create a custom configuration for that game. So instead of a standardized settings profile, you can have individual settings profile and make your games much more efficient. This is called the local settings and the overall settings is called global settings. Let's test some games, shall we?
Welcome to the Keihachi Mishima. Get ready for the next battle. Final round. Fight. Devil.
So there we have it guys, the complete guide to RPCS3, the PlayStation 3 emulator. Even with this guide you might run into some issues, just drop down a comment below and I will try my best to help out. Anyways, I hope you guys found this guide helpful. Thank you so much for watching. Catch you guys later.